Good afternoon, everyone. Thank you very much for joining us today. We're going to be talking a bit about DNS, DNS security specifically. I have a few slides to take you through, and then we'll try and give you a bit of a demo on some of the technologies that we're using to protect DNS. And then we'll kind of wrap it up, and I invite you to fire out a bit of a Q&A with me. No question is a dumb question, and likewise, any tough question, it's always entertaining to see how I might answer it. So on that note, let's begin with the slide deck. I'll just share my screen for you. Right, so today we're going to talk about why DNS is your first line of defense. So a bit about me. So I'm a solution architect at EfficientIP. I essentially design what we call DDI solutions, which is DNS, DHCP, and IP address management for some quite large organizations. I have to say it's quite exciting. Sometimes global deployments, organizations with massive supply chains, fintechs, a real broad spectrum. You'll see in a minute when I give you the logo slide. And I also participate in the security community. So over here, with OWASP London, also very much into the DEF CON chapter here, 4420, ISSA, London chapter as well, and further afield, as well as maker communities and so on. So just a bit about EfficientIP. So we've been actually now working in the industry since about 2004 was when the company blossomed and entered the American markets. We basically have operations that are based out of Philadelphia for the USA, Singapore for Asia Pacific, and Paris for Europe, Middle East, and Africa. So we kind of focus around an open ecosystem integration philosophy. Very much involved in things like application infrastructure lifecycle automation. We're doing some fairly sort of fun things around intelligent application traffic steering. There's also the adaptive DNS security we'll talk about a bit today. And essentially what we're trying to do for customers is, improve efficiency, make life easier for those engineers out there that are having to manage these large scale networks, reduce the risk of managing those networks, and of course, lowering the cost of management. So that's a bit about us. We're very proud to share with you some of the companies that we work with. Certainly Netflix, the guys that kicked off Chaos Monkey, I'm very proud that we work with them, but also massive companies like NXP out of the Netherlands, Boeing in the USA, as well as also the academic institutions, McGill and likewise. And you'll see also we're working with some fairly large-scale telecommunications operators, Telefonica, Singtel, also helping systems integrators like Orange. So yeah, we get to see a lot of networks. So we're going to talk about network security, why DNS is a favorite target for attackers. Why are you making DNS your first line of defense? I'll try and explain what the impact is here, give you that demo that I mentioned, and some key takeaways. So it's kind of an obvious one that the cyber attacks are on the rise. I was trying to warn our National Center for sort of cybersecurity here when the COVID era kicked off, that we were going to see a massive increase as people lost their job. They would maybe become bad actors. You see a lot more amateur attacks taking place. Nation states are now getting more involved because of the observability in terms of their ability to do things like people trafficking and the drug trade. There's a lot more surveillance capabilities that are capturing them. So they're moving their operations into digital. So it's really is a significant issue. And of course, with that, they're becoming more and more sophisticated. It is cat and mouse, and it's rather frustrating, really, that you'll have a great vendor will release a technology. The most recent, really, sort of, which was kind of called, was the whole next generation firewall scenario. But it's catch up. These organizations are able to acquire these technologies, reverse engineer them, identify issues, look at workarounds. They have a massive resource available to them to be able to achieve this. And then, of course, the other scenarios with all this activity that, security operations centers obviously being overwhelmed with, non-relevant info, what we call false positives. There's a lot of data. I mean, people are talking about their data lake versus your data lake versus a vendor data lake. It's just an avalanche of data, really. So one of the things we're going to talk about is that why DNS is actually often getting abused. So if we just talk a bit about, what we've been hearing and seeing, this is reports that we've been sort of running now for quite some years to gather this kind of data. Essentially, you'd be surprised to think actually 91% of malware is using DNS services. It's pretty shocking. And of course, there's the usual stats of the downtime, the cost, and so on. This is, this is the business case. Why would you want to invest in DNS security technologies? These are some of the highlights. And it's become a key component in a lot of the attacks that we've been seeing. And the problem is it's hidden from the traffic. There's a very key technique taught by spies and also bad people: hide in plain sight. Where better to hide than in a mass of DNS traffic? So one of the reasons that it's a favorite is there's a lot of fun things you can do with DNS to give somebody a bad day. I mean, there's DNS hijacking, there's cache poisoning, 0 days that are using, manipulating. They're getting into the network thanks to the DNS techniques of an abuse of the protocol, phantom attacks, DGA. Sorry for the acronym. So domain generated algorithms. So essentially, what they're doing is, you've probably heard of this. A malware is trying to again hide and obfuscate. So they don't have those sort of easy to identify domains in their code. If you're trying to reverse engineer it or get through it, they've got an algorithm that's actually creating in real time the domain that they want to use, and they've gone and registered all these domains. So again, it's how do you keep track of this? NX domain tax, obviously very annoying as well. You just really tire out a DNS server. It's like somebody coming to the doorbell every time and ringing the doorbell. You go down to answer it, there's no one there. I mean, it's pretty frustrating. DNS flooding, well, classic. This is where the denial of service industry is very active. The challenge there is a lot of the technologies that are out there are very much threshold based. I'll allow you to flood me until I can't be flooded anymore. It's not very intelligent. And then DNS tunneling is the one we're going to talk about a bit today. And in essence, we're just giving you a highlight in terms of the infection chain, how things take place. We're getting much better at perimeter defenses, but insider threats are really our biggest concern. And once they've got the tech on a USB key, they've put it in the machine, it's automatically installed the malware. Your perimeter, what about it? Well, it doesn't matter. Somebody's found another way to get inside your organization, inside your data center, and set the tone for a potential command and control scenario. So why is it a favorite? This is one of the things I was sort of alluding to earlier. So everyone needs DNS. There's no way about it. It's the internet phone book. So I won't wax too lyrical on that. It's fairly clear, I believe. What is not less clear is that DNS is open by design. So for all the engineers here that like reading the RFCs, you'll know very clearly that DNS has to be open. It will not function if it cannot recurse or forward. So recursion is where it's going through the sort of top level domains, and it sort of finds the name servers for that, then where the .coms, which are the ones in the .com. It's got to get out to the internet to do that. Likewise, if it wants to forward requests, let's say you guys are using Cloudflare, Quad9, Google, another DNS service provider, OpenDNS, Cisco, whatever, that kind of thing. It's got to get there. It has to go out, and a response has to come back. It's open. And this is the issue. It's open, but it's not effectively protected. The challenge that some of our favorite perimeter technologies have is it's the load, and being able to then process and do intelligent things to analyze patterns. As yet, there is no one doing it in that space. So essentially what we're talking about here, of course, is this dual role of in the infection chain. It's both a threat vector as well as a direct objective. So what I mean is that yes, we can attack the DNS and make it a bad day, but that's not really the interest of most attackers. What they want to do is use the DNS to do bad things. So essentially, threat vector. So just a bit of a diagram to sort of give you a feel for what we're sort of saying. So the device infection, people install maldoors and backdoors, as I was referring to, create the command and control. Then what happens? What are they going to do with it? Well, data exfiltration, very key. The black market in competitive intelligence for industry information is massive. the dark web makes it so. It's a serious issue, as well as obviously then using this information for later further attacks on either that organization or their supply chain, having identified who they're working with and the weak points. It's so the data exfiltration is key. Pulling out passwords, social security numbers, SSH keys, that kind of thing. And then, of course, to be able to do this in a slick way is obviously with a command and control infrastructure that is going to be able to use this DNS protocol in order to operate that infected device without actually being in your network, on your network, because the device is already infected and it's now talking outside of your network using the DNS protocol. So again, I mean, we're kind of banging the nail in here, but the thing is, it's true. I mean, there isn't, you go look at your next generation firewall settings, go and have a look at your DNS security settings, go and tell me where you can find the ability to maintain your DNS service without actually breaking it or stopping it. So hackers are including confidential data in their DNS requests. These DNS requests are then going to the domain here. Our scenario domain is confidential data accomplice.domain.com. As we said, it's bypassing the infrastructure because it's going through the DNS infrastructure. So it's not in the cache, it then goes to recursive. It will eventually find that target name server on the other side of the internet. And then, of course, the information has been stolen. So these are the kind of the actions that we're proposing that you try and take in order to make it your first line of defense. So you can use DNS data to gain network visibility at the user level. So this is kind of like the conversation around passive DNS or OSINT, open source intelligence of DNS. By knowing who is using your DNS, how they're using your DNS, and when they're using your DNS is very valuable information. Being able to capture that is very popular. So popular, unfortunately, that your SOC will often turn around and say, we want all the answer logs, we want all the query logs of your DNS. And you go like, you know, we're not a Five Eyes organization where you capture everything. How are you going to do event correlation quickly without investing serious amounts of money in big data storage? And this goes back to what I was talking to you about earlier with like your lake, my lake, all that data, having to go through it, make event correlation. It's expensive, to say the least. But it's something that we're recommending you should be able to do. So it has the granular visibility over 100% of the IP traffic. And then you've got the contextual information for behavioral threat detection. So this is now playing into what we're going to obviously suggest about how we approach it. But when you're capturing this information, you can do quite a bit more in terms of the ability of pattern analysis. So DNS is the key here is that DNS is seeing the threats at probably the earliest point in the IP traffic flow. Very, very important to understand in terms of, you know, that alert. If they bypass the antivirus systems, if they've been able to infect a system that hasn't already been patched, isn't already got the best security controls that you could afford, they've figured out how to hide there. The only time you're going to know there's anything bad is when they stick their head up to do something. And this is when they're going to be using DNS. Because they won't obviously want to use a static IP because they're changing their IPs all the time. So again, another reminder, why DNS? Why, you know, because of that reason, they're able to manipulate the DNS records with the IPs that they want to use for their command and control servers. So what we're talking about here is the ability to do advanced real-time analytics to obtain end-to-end security. God, that's a mouthful. But essentially, it's security from the source to the destination. So attacks are being analyzed for each DNS client. Then obviously they're identifying malicious destinations with threat intelligence and domain reputation, belt and braces here. But really, what we want to be able to do is actually detect these attacks, or these abuses through either data exfiltration, DNS tunneling, or zero-day malicious domain use. And obviously domain-generated algorithms as well are definitely a flag. So to intelligently protect against attacks with adaptive security response, a unique solution offering adaptive countermeasures according to analysis of the threat. So this is what we're basically talking about, to be able to prevent, contain, and block attacks and mitigate the risks of the false positives. Nothing worse than a part of the department has started a new project. They've had a flash mob of interest, and it creates a false positive, and all of a sudden they're offline because your security controls have misunderstood the scenario. You've just gone for threshold-based analysis. So what we're trying to propose is a much more granular approach. So yeah, you know, We can block the source of IPs of the attacks. Yeah, that's pretty easy. We can rate limit DNS traffic. That goes kind of to the threshold thing. Yeah, pretty easy. But what we can also do, and this is my fun, I love that we can redirect the traffic to say another destination DNS IP as a honeypot and watch them try and play with that. We can quarantine, which basically allows for the device that's been infected to not allow to go and recurse out to the internet, but it's still able to use make requests to the cache for records that are in the cache. So if you think the cache is kind of a horizontal layer across your entire organization where everyone is using that cache. So it's going to be all your common domains, all your operational domains, all your internal domains and their resource records are going to be in your cache. So it's okay to go and ask for what the IP is for, my R&D lab.yourorganization.com. That's fine. But it's not cool to go out to Mr. Nasty Command and Control DNS name. And this is how quarantine could really come into play. So it's a very, very cool technique. And then, of course, you can do some other things, to try and frustrate, where you can force the DNS response, where you can say, well, actually, let's just tell them it's this answer. That could be fun as well. And then we have a more powerful technique, which is building on top of that idea of quarantine, which is where we're activating what we call rescue mode. And what that'll do is it freezes the cache. So do you remember, you think, well, hang on, what if that cache is dynamic? What if other things are going on? What's the likelihood two different infected points are both sort of manipulating, and then one would still be in the cache? Well, freezing the cache, game over for abuse of the DNS protocol. And sometimes you need to have kind of a panic switch. But the key is your operation is still using all those domains that are in the cache. You're still operational. Your apps are still working. Your automation technology is still working, as an example. So the idea is to strengthening application access control with client-based DNS filtering policies. So what are we on about here? So essentially, we're tying our classic. The doorbell has just rung. I'll have to let that one go, I think. So the client query filtering policies, essentially what that does is it's an allow and deny lists, allowing to have filtering policies both on client and both on domain, which relates to those countermeasures that we're using. So that can be very useful in terms of IoT devices, where you're often buying stuff that's all baked in, even if they might be able to update the firmware. Generally, the security posture of IoT is not good. I'm going to have to answer the door because they keep ringing and it's going to distract us. 2 seconds, classic, sorry. Oh, nothing like a genuine presentation in the COVID era when you're working from home. Right, thank you for those that are still here. So I was talking about the IoT issue, wasn't I? So essentially the problem is obviously patching these devices, getting access to them. But if you have the ability to use dynamic allow and deny lists, then you actually have got a layer of security over your IoT and infrastructure that mitigates those risks. Let me pause for some water. Right, on we go. So as I mentioned, the granularity down to the individual client, reducing the exposure risk at the earliest point in the flow, and obviously the DNS-based client access control to virtual apps and infrastructure. All right. So we integrate DNS with the security ecosystem to automate and orchestrate responses. So what we're able to do is that when we're detecting behavior in the DNS protocol that is suspicious, that is nefarious, that is abusive, we can then send that event, not all those answer logs, not all those query logs, that single event to either DNS analytics services, threat intelligence services that are using AI to use these to do event correlation, and of course your traditional SIEM. So enterprise-wide detection is improved, spreading of attacks is being prevented, we're accelerating remediation, and obviously we're able to provide what we call DDI-enriched information. So one of the layers that has been neglected in the network engineering space has been around DDI, DNS, DHCP, and IP address management. And what we're able to do is push that event data to your security policy orchestration system, to your SIEM, to your SOC, which allows them to then make their policies richer, more detailed, more granular, more specific, which is kind of a clue into how we're also enabling zero trust scenarios. Because let's not forget, A device connecting on the network needs an IP address. It needs to use the DNS. This is a very important part of your ability to implement a zero trust policy, by being able to actually apply policies to those particular behaviors. Oh yes, and we're bridging the security silos and delivering end-to-end automation control. Sounds pretty good. Okay, so blocking command and control. This is the fun bit. Just as a heads up, what we were doing earlier, if you remember that graphic, essentially we've got an external endpoint, the command and control server, and we've got the infected endpoint inside the target network that the command and control owner is trying to obviously abuse. So the scenario is that we're going to be sending a request back to CNC to say, hey, CNC, let's have some fun. So when CNC hears that request, it's going to say, yep, let's have a chat. Let's open up a command channel. And it's going to do this undetected because it's going to be doing it through DNS traffic. So it's able to pass through those security investments that you've made and basically get out to the public in the public network. Now, so to establish the control, as I said, internal device is going to start a command channel. We're going to have a look at the DNS traffic that's taking place, moving backwards and forwards between the 2 points, showing that activity. The command and control service is going to then execute a few commands. We'll probably cat some text files, pull out some information there, maybe even push some text into a text file on the infected endpoint. And we're going to see this all. These are commands being observed on that. Then the next step, obviously, is, well, yeah, okay, so you've shown us the bad. How do you fix it? The mitigation. So we're going to do exactly the same process again, but this time what we're going to be doing is we're going to have our Guardian technology that is able to do DNS transaction inspection, and that's going to be able to detect what's going on and then do something about it. And then we can also see these events appearing in a log collector, which gives you that sort of example of how we're saying, when an event occurs, it's being sent to another system to bring that system into play with regards to the attack that's taking place. Right, live demo time. More water. I'll be honest, it's not that live. I recorded it just in case something went wrong. Unfortunately, something else went wrong with the doorbell, but we'll live over that. Okay. So, allow me to talk you through the recording. So over on the left, in the purple, is our command and control. And on the right is our infected endpoint. What you see there is a text file that we're just watching, because what we're going to do is try and change that from the command and control, and then when we do, the text will appear. So we'll also have a look at some of the contents on that infected endpoint. And then down at the bottom is where we're going to be observing the DNS traffic, essentially doing a TCP dump. So we can see that when these two are talking to each other, that DNS traffic is passing. So the heads up is the timestamp, so you can see that I was recording it the other night. So the first thing we're going to do is start listening for the infected device to call out to command and control, which it does now. As you see, a session's been created. They're now talking. At the bottom, we've got the DNS traffic going backwards and forwards. So now in the command and control, I'm going to now use that to connect. And just as a heads up, this is on GitHub, DNS Cat 2. It's been there for 6 years. Okay, 6 years this has been available. So we're now connecting to a shell, or creating a shell that we're going to work with. There we are. There's the shell setup on the left. Now we're going to just do a few commands from the command and control. So obviously we're able to see the text, sorry, the contents of the directory. Now we're going to push some text from our command and control into the text file that's sitting in that infected endpoint. We've called the text file Naughty Boy. Forgive me for my humor. As you can see, that is now working, it's now in control. So what do we do next? We'll obviously just highlight the timestamp. That was at 2:06:10 roughly, UTC, I think. And as we see here, we're going to go to the logging solution. And the idea is that we picked up the log that our solution detected it, which it did. Timestamp, yes. So obviously different. That's UTC. The other one was BST. And a trigger has been armed due to DNS suspicious behavior. But you see there, the action is to log it. So we haven't done anything about it. We're just logging it. So from an observability point of view, it's handy. But really what we want to be able to do is see, mitigate that risk. So we're going to start the whole process again. Just shut down the command and control listener. Likewise, the call out. Tidy up the screen so it's a little easier to see. As you see, there's no more DNS traffic going backwards and forwards. And currently, the text there is "I'm now in control." As you can see, same text file. Oh yes, so I was going to change the text to something a little bit more less. I'm not in control yet, I believe is what I went with. Yep, there we go. I'm not yet in control. Kind of like today on this presentation. So we'll just keep an eye on the timestamp as well over there on the middle right. Oh, and the other thing we're going to do there is we've now turned our guiding technology saying, don't just log it, do something about it. And we're going to quarantine it, and I'll talk you through the quarantine and how that's working in a second. So here we go again. We're now listening. It's now calling out to the C2. You see the DNS traffic is going backwards and forwards. We've had a session encrypted here. We're now going to do that thing to connect to the thing. But what I'll just highlight, you'll see the DNS traffic on the bottom right is going out, but there's nothing coming in on the bottom left. Okay, that was pretty quick. It's we're talking milliseconds there. We're still trying to do something, and what you see now, the call out from the infected device was not able to work. Let me just, there we go. So essentially the communication's been lost, which is exactly what we wanted to do. We wanted to be able to break this and stop it. So we're going to go back again, have a look in the logging system. As you can see, we've got the trigger armed, and you see the timestamp. And essentially we've done this action quarantine. So we'll use some specific examples to explain what quarantine is doing as per. So remember, the quarantine allows you to talk to the cache, but it doesn't allow you to recurse or forward from the cache to get new domains. So what we did, we're looking now, obviously, at these are the domains that are in the cache. Just picked a few there. And then you'll now see me trying to go back up to remember where because I'm lazy, I don't type the commands. So I'm now going to dig, I think, dark reading and light reading, because they're in the cache when I eventually get there. Yep. There we go. Right, so those are these, and you'll see down at the bottom the address is being requested. If you can see right down there, it says light reading and dark reading. It's a bit small, but hopefully you can trust me on that. So now we're going to dig a domain that isn't in the cache. So for those who are observant, you will have seen I didn't have infosecurity.be in the cache. So let's go get it. And essentially what it's doing now is it's requesting, the client is requesting, and it keeps requesting, but because it's not in the cache on our Guardian solution, it's not going to get an answer. So this is the point about the ability to use quarantine as a mitigation technique. So your operation can still work, it can still be running. It's only data that's not in the cache that cannot be accessed in terms of DNS lookups. Right. Forgive me if I started talking a bit too quickly for the non-native English speakers. Right, so if we now go back to our slides. Thank you for observing that. So the three key takeaways I'd like you to try and remember from this talk today, apart from the doorbell ringing. So 91% of malware abuse is using DNS. Okay, it might be an old technique, but it's low-hanging fruit for the black hats out there, and they're very happy to keep using it because, and this is the thing that really breaks my heart. Here's a company that has a solution to stop this, and how many people are actually deploying these techniques? How many people are being sold the promise, oh yeah, we've got this cloud-based threat intelligence platform that's going to do it all for you? And of course, you only need one attack to cause loss of life, cause financial ruin, brand reputation. Just needs to be one attack, one DNS domain that they didn't spot. So this is why it's quite upsetting to see. Also, so DNS sees virtually all internet traffic. So provide valuable data to detect data exfiltration and other threats. You know, it's super. I mean, this is seriously good. I try to evangelize open source intelligence techniques because it's more cost effective over the longer term to have a strategy. Yes, complement it with threat intelligence services. There's some brilliant guys out there. I won't name them all, but you know, you've even I think it's a Anomaly. There's a Dutch company that's really not rocking it. They're combining threat intel feeds from many different areas. They're then customizing it per industry vertical, organization size, and so on. But you know, it's an expensive effort. So the fact that you can generate this yourself is kind of a smart move, in my opinion. And then, of course, combining the client behavior analytics with the threat intel gives you this concept of being able to actually affect the zero trust strategy in a more cost-effective manner. So it is definitely a complement to anything that's regarding zero trust initiatives that you're considering right now. This is essentially what EfficientIP we call our 360-degree DNS security. So right at the very top, unfortunately with the DNS, you've got to respond. It's not like the fun of, say, BGP diversion and trying to ensure session affinity. Latency will eventually be the death of you. You've got to soak it up, essentially. So we do a solution that will do 17 million queries per second. It's the fastest DNS service out there, appliance technology out there. So we cover that sort of top end. And then, of course, out of the box, you know, we've got, you know, sort of, you know, the use of, you know, that allowed denialist concept in terms of DNS firewalling. We also recommend, you know, use cloud DNS. We're able to orchestrate cloud DNS providers from our solution, which means that you get access to a global anycast network for really not a lot of money. You don't have to go and buy that tin, put it in lots of data centers around the world. You're leveraging a commodity service, essentially, and it is a very good investment. And several of our customers who were initially running our solution doing public DNS went, yeah, this is great. Let's do that. Let's decommission those, repurpose them to use elsewhere inside the organization, and we'll go cloud DNS for all our public DNS. So it's a super thing. And then, of course, you'll probably notice we have a relationship with Umbrella, Cisco Umbrella. So we were the first vendor to actually work with Cisco Umbrella, providing a DDI complementary solution to their Umbrella service. And it works great for us because we don't do what I call off-site protection. So we don't have agents that we deploy to mobile devices or tablets. That's not our space. Umbrella is very good at that. So it's a very nice marriage of technologies. Again, it's bringing obviously probably the best threat intel out there. But as I said, it's not the only, it will not be the only solution. And the other challenge, of course, is, you know, it's kind of a north-south design. We're able to do the east and west in terms of DNS. People could be using your DNS inside your organization so they don't get spotted. They're not even recursing out. They've set up a listener in one part of the organization that's playing DNS server, and they've set up they've got infected device on the other, and they're exfiltrating across your organization. That is not fun. And you imagine, you can't police everything all the time. If you have different tiers of security, the hackers, the bad people, they're going to go and find where your weakest point is, your Achilles heel, and settle their C2 in there. So you've got to really understand your threat model and do threat modeling across your entire organization to know where those threats could be, to ensure these things don't happen. And then have the ability to, when things do observe, to be able to actually identify where they're coming from. So in the example of that Achilles heel, if you've got our technology, which is observing the east and west traffic, you're seeing DNS abuse, you know from which IP this is coming. You'll know which IP made that request. In your IPAM, you'll be able to go and look up in seconds and go, bang, who's got this IP? Oh, it's a DHCP lease that's been granted from this subnet. This is part of the, you can remediate. So something for you to consider. Right, questions, please. I'll stop sharing. Thank you very much, by the way, for attending, for everyone who attended. I do believe I've run over a little bit, so apologies for that. There's a chat. Let's have a look what's in the chat. April 1st, yes, absolutely. Oh, you have no sound, shaky sound. Okay. Okay, thank you. Thank you, everyone. Thank you. Yes, I do believe that hopefully we might have to redo the talk so we don't have the so we don't have the doorbell essence. But hey, at least it's thank you very much. I hope you've enjoyed it. Please do feel free to reach out to our colleagues to talk about this further. We can do one-on-one sessions and talk a little bit more about our secret sauce with you in a private way. And again, thank you very much for your attendance. Yeah, so, well, everyone's got a little bit of something. Essentially, if you were to look at it in tiers, the enterprise Fortune 500 are pretty good. They're doing their best, not always working with us. You know, I would say in terms of the threat landscape for an attacker, you're going to be probably thinking about 85% of organizations are going to be good targets, of which maybe I would say all the mid-markets, all the non-profits, all the healthcare organizations, that anyone who has legacy tech, anyone who's got technical debt are high risk, because they won't have even solved the other problems, let alone thinking about this. Because again, everyone said, well, DNS is open, what can I do anyway? I've got to need to work on my endpoint security. I can't even afford silence or in silo. What am I going to do? So it is quite disturbing in terms of the amount of companies that are actually out there that are being abused. This was very popular with some of the when Anonymous was more active, and they were doing data grabs and dropping that out on the internet. The Panama stuff. All these were brilliant techniques for exfiltrating data. No one noticed. So yeah. Typical implementation time, such as fast, rockingly fast. So all you need to do, essentially, let's just say that currently your DNS, let's say you've already pretty good on DNS. You've got an internal Anycast network with an IP that say like 10, 10, 10, 10. All your devices are using that, and they're going to say say that they pointed to the 10, 10, 10, 10 points is a virtual IP that points to say 3 data centers where there's a DNS server. It's a swap out. You literally just rack up our solution and give it that IP, or give it another IP, but normally give it that IP, add it to the Anycast network, decommission the other one, you're done. I mean, it's a 10-minute job for DC. What's quite nice actually with our solution, we do a thing called, actually check out a video called Network Function Virtualization with a DNS from EfficientIP. So we're able to do horizontal DNS scaling, something we know we talk to with telcos, and what they're able to do is that when they provision a new DNS Guardian service, they can juice the cache from the existing DNS environment into that server, so it's immediately live. It's not going to have to go and recurse and go and ask all for those DNS requests again. It's got the latest cache with the timestamps respected. So yeah, it's deployment is super fast, and we're now doing stuff where we're doing this with Terraform and Ansible. More Terraform because it's a bit more cool. There's more things you can do around Terraform models. So yeah, you can put it straight into your automated infrastructure, sort of infrastructure as code designs as well. Yeah. Any other questions? Very happy to answer. Yes, agreed. Absolutely. Yes, there's loads on reputation. There's a really good talk that was given in FOSDEM 2-3 years ago called the snowshoe attack, where they're trying to develop algorithms to essentially look at the time a DNS domain had been registered, how long it had been registered, whether that would impact as a pattern analysis to infer this could be a bad domain. What we're now seeing in some of these reputation-based providers, they're trying to build out these kind of algorithms. Say, like, if it walks like a duck, quacks like a duck, it must be a duck. But you need the data. What is fun in our solution is you don't need the data. It's about the second or third packet is enough of a clue for us. Sometimes maybe a few more packets. I'll give you an example. If one of the demos I like to do is essentially I have about like 50 clients. I have 5 million domains. I basically box up all the domains as requests across the 50 clients, and then I just take a very small text file that I've encrypted, that I'm then going to use it through a standard exfiltration technique, but I seed it across the 50 clients, and we can still spot it. The point being is because the client has made the request, it's gone into the cache, and it's data points in our data lake, in our DNS data lake that's on our appliances. Yeah, yes, Yuji, with pleasure. I'll pass it over to our marketing team, and they'll liaise with you to make sure that you get the information you've requested. I'll just do a quick copy of that as well, so I don't lose it. Okay, I think we've gone. No, we're still live. That's great. So yes, any more questions, feel free. I have still happy to answer more questions. Pleasure. Okay, I guess that's a thumbs up from Emily that I can now close the session. Thank you very much. Well, keep safe, everyone. Happy Easter. And yeah, fingers crossed we might be able to do this in person next year. Thank you very much for joining us. Bye-bye.